Okay, so file information. So they introduce us to another function, the stat. So man start system call, it gets the status of a file. On success, 0 is returned. On error, -1 is returned. So let's read about stat. Okay, so you can see there are different functions. So it has a family. So stat, fstat, lstat, fstat, statat. Okay, so what it does is it gets you the file status. So these are the header files to be included. So these are the prototypes. So we are saying that the start now, number one, you pass in a path name, and then you pass in a start buff, a pointer to a start buff. The fstat takes in a file descriptor and also passes in a start buff. Yes. So the lstat takes in a path name and also takes in a start buff. So what do they do? So this is another way to include them. Okay, this is for the fstat. Okay, start at. So here you include the directory, you include the path name, and then the start at buffer. Okay, the start buff. Yes. So let's just go to the description. So the function returns information about a file. So the information is returned in the buffer that is pointed to by the start buff. No permissions are required on file itself, but in the case of start, fstat and lstat execute. So execute search permission is required on all the directories in the path name that leads to the file. Okay, so an execute permission must be available. I think we should take a break there. I'm trying to, if we do this, guys, are you with me?
Yes.
All right, so let's try to understand something. I want you to see this. This is my home directory. No, this is not my home directory. Sorry. Yes, this is my home directory now. Now, these are folders, right? Bin is a folder. Boot is a folder, is a directory. You can see all this with D. Starting with D, they are directories. But I want you to notice that they have an execute. They have an execute permission. They have an execute permission. They have an execute permission. What this means is that I can open, if I go to home, I can open this directory. Do you understand? When I double click on a file, it's like I'm executing the file. That's what happens when you try to double click on a file. It's like you execute the content of that file. Do you understand? So okay, I think that's not the right word to use. When you double click on a file, you open the file, but when you double click on an executable, you run the executable. For directories, they have the execute permission. If you set the execute permission, then you can cd into the directory, you can open the directory. Do you understand? That is what this execute bit does for directories. Because if you think of it, you say a directory is not an executable, but you will now ask why it has the execute bit set for it. So for you to be able to access that directory, it needs to be executable. This execute permission must be set. So that is what they are talking about here. This stat. So this stat says, but in the case of stats, fstat, lstat, or fstat, lstat, the execute search permission is required for all directories in path name that lead to the file. So the execute must be set for them. So that's just for us to note. Stat and fstat retrieve information about the file pointed to by path name. The differences for fstat are described below. lstat is identical to stat, except that if path name is a symbolic link, then it returns information about the link itself, not the file name that it links to. And fstat is identical to stat, except that the file about which information is to be retrieved is specified by the file descriptor. So the stat structure. So let's see what is included in this pointer that you have to pass to it. So all these system calls return a stat structure which contains the following fields. So stdev, so the ID of the device containing the file, inot, the inode number, the mode t, the file type and the mode, nlink, the number of hard links, the uid, so the user ID of the owner, stgid, the group ID of the owner, sarid, the device ID if it's a special file, st size, total size in bytes, so the block size in the file system, and then the number of 512 bytes blocks allocated. So it gives you all of this information. So the order of the fields in stat structure varies. So okay, we can leave all this out. I think we can just let's jump to the return. So on success, 0 is returned. On error, -1 is returned. Do we understand? Hello?
Yeah, I'm here with you.
Okay. So what we use this for, the application, why do we need it? Why do we need this stat, fstat and co in building our own shell? You know, if I come here and I want to run a program, okay, inside here now I have different programs, abi a.out, efw, hello and co. If I type pav, it runs. If I type hello, it prints hello world, so it runs. But what if I type something that is not there? You see, it does something else, right? It gives me different suggestions. or let me say I do so the reason why it gave me a return this for me is because there are maybe it's trying to say there are possible programs that may have that name, so maybe I want to install them, but of course this one there is no possibility. Do you understand? This one has no possibility, so it now returned this: no such file or directory. No such file or directory.
I think the first one failed because you were trying to say it felt like it at HT.
Yes, it felt it.
If you had put .stat, it would have been returned. It would have said there's no such file or directory.
Okay. Oh yes, thank you very much. Thank you very much. Okay, so it still says no such file or directory. So what happened? Why is it saying no such file or directory? What this bash had done is, number one, it checked this that I typed here, right? It checked this directory with stat, and that stat returned -1. So because that stat returned -1, it said there is no such file or directory. Do you understand? If I type ls is found. If I type jw, is it not found? Do you understand? But this time around it came here. Why didn't it say not no file or directory? Is because it went through, it's first looking at this, that okay, this is likely a program name, it's likely an executable, so it's going to search through the path variable. So checking through the path variable, so it's going to check through this, the first one. It will check through this variable. It doesn't find it. It comes, it checks through this, it doesn't find this, it checks through this, it doesn't find. So it checks through. When it doesn't find anything and it is looking like it may be a program, then it brings all these suggestions. So we don't need to, we are not looking to give suggestions in the code we are writing. My battery is running low. We're not looking to give suggestions. So but what we just need to do is, eventually we are going to want to search through the path variable, of course, and then also when we don't find it, when we don't find that particular path, of course stats would have returned -1, and then we will now tell whoever is using our program that we will display an error. We can display this same error: no such file or directory. Now in case we find it, then we can now go ahead and fork and then execute. Do we understand? Hello guys, do we understand, please? Hello?
Yeah, right here.
Okay, so I don't know how much juice this can go. 24 minutes. Okay. I really want us to be able to test something here. So what you can do is, I want you to copy this program that they used here. I want you to copy this program, and then I want us to try it. So in the program, they call ls this and this to it. So you see ls not found, bin slash ls not found, user bin this thing not found. So let me just try to build the program first of all. So guys, let me just explain what this program is, right? So remember, first of all, we spoke that stat takes in a structure, it returns an integer, but this is not the integer. Sorry, this is not the, this is just going to be for the loop here. Sorry about that. So okay, of course they tested if the argument count that they pass to this program is less than 2, then you would say this is the usage, so it's going to return an error. But if not, they loop through argv, they print the argv, and then they say if stat. So they search for that file path that was given, and then this is the file structure. So they said if it returns 0, remember on success stat will return 0, print found. So if it doesn't return 0, that means it will return -1, print not found, and then the I++. So if we run this, so if I do this, it will not work. So if I do ls, you see this path is not found. If I type ls, it's not found. If I type ls, usr ls, so you see that on my system ls can be found in these two directories. Let's see if we can, let's use this to, so let's use it to look for another in here we have hello abi. So if I do /hello, you see found. So the application of stat for us is to find out if a particular path name exists or not. So that's mainly what it's going to be used for. So then I think what we can do is we would, let's attempt this on our own. Write a program that looks for files in the current path. So what you basically want to do is you take you write the usage is going to be similar to this. Okay, the usage is going to be similar to this. So the person is going to do, for example, this person is going to write stat, for example, ls, and put ls. So the person will first, what you do is you first print ls, and then you now print whether it is found in the path variable or not. I think that's what they're asking us to do. So it says usage, which write a program that looks for files. So it will just look for the file. So if it is found in any of the paths of the paths in your path variable, then it will print found. If not, it will print not found. So it's something similar to this, but try. If you are asking how are you going to get this path, for now there is a function you can use. There is a function you can use, and that function is called getEnv. That function is called getEnv. But this getEnv will not be allowed when you are building your shell. You have to write a similar function. Do you understand? But while you are testing this, you can use getEnv. So what I want you to do is read about getEnv, see how getEnv operates, then use it to get the path variable, and then apply what we've learned so far. We've learned about string talk, how you can split strings with a delimiter. So apply all of that, and then whatever you split, look for a way to add the argument supplied to that thing and check if it exists with stat. So that's just the hint I'm going to give. So let's try to work on it, please.